Okay, let's look at, let's compare weak electrolytes and strong electrolytes. Is that clear? Is that clear? Let's compare weak electrolytes and strong what? Electrolytes. Let's compare weak electrolyte and strong electrolytes. Yes, and strong electrolytes. Before you can appreciate that, you should know what an electrolyte is. True of us. So, what do you understand by electrolytes? No, listen. Electrolytes. Are you listening? Electrolyte is any compound in a solution or molten form that conduct electricity. Electrolyte is any compound that conduct electricity in molten or what? Solution what? Form. Is that clear? Yeah. Remember I told you that it is an electrolyte that you put into this that place you see dots. That you see there in the electrochemical cells. In the electrolytic cell is called what? Electrolytes. So electrolyte is sometimes any compound in molten or liquid which in molten or liquid forms conduct what? Electricity. That's an what? Electrolyte. You can put it down. So electrolyte is any compound which conduct electricity in molten or liquid what? Form. So in molten or solution form. Are you good?
Yes.
Huh?
Yes.
Okay. Okay, let's look at that comparison between what? Let's now compare. We have weak electrolyte and strong what? Electrolyte. So let's compare. We use this comparison to give examples of each of them and other things we need to know about electrolyte. Is that clear? So comparison between weak and strong electrolytes. Strong electrolytes completely dissociate into ions in solution. Strong electrolytes completely dissociate into ions in solution. Strong electrolytes completely dissociate into ions in what? Solution. Is that clear? Strong electrolyte completely dissociates into ions in solution. While weak electrolytes only partially dissociates. While weak electrolytes only partially dissociates into ions in solution. While weak electrolytes only partially dissociates into ions in solution. While weak electrolytes only partially dissociate into ions in solution. Is that clear? While weak electrolyte only partially dissociate into ions in what? Solution. While weak electrolyte only partially dissociate, partially what? Dissociate into ions in solution. Let me explain. Something like sodium chloride now. If it dissolves in a solution, it will form sodium chloride solution. If you add water here now, it will form sodium what? Chloride what? Solution. This thing means that the ions, it has dissolved. The ions have, because you combine it with water. Water has two opposite ends. We call that water is polar. There are some solvents that are polar. If something is polar, it means that it has two poles, two ends. One is partially positive, one is what? Partially what? Negative. So when water now, here is sodium ion, here is hydrogen ion. So here is partially positive, partially what? Negative. When they come in contact with this sodium chloride, they will solvate this ion and impact positive charge here, impact negative charge here. Is that clear? Now this is when it's how it appears as a solid sodium chloride, and this is how it appears as what? Solution, aqueous. Is that clear? Now this thing now are like this. They have been separated into different ions. This is how it appears in solution. So strong electrolytes will have complete dissociation. Everything dissociates. No, this place now is there's no ion here. Here is where you have the ion. But strong electrolyte, everything dissociates into what? Sodium ion and chloride ion. But if it is if it's a weak electrolyte, if it is a weak electrolyte will not dissociate completely. Some part will dissociate, some part will still remain like this. Is that clear? But if it is non-electrolyte, it will not dissociate at all. There will be no ion at all. Is that clear? But sodium chloride solution is a strong electrolyte. Sodium will form a strong electrolyte. So everything will dissociate. Is that clear? It will dissociate completely. If you wish to write it as a dissociation equation, you have something like this. Is that clear? Now, if you can find no issue. I just use it to explain what dissociation is. Is that clear? Okay. Next one. Strong electrolytes have high conductivity. Strong electrolytes have high conductivity. Strong electrolytes have high conductivity. Strong electrolytes have high conductivity due to the presence of a high number of ions. Due to the presence of a high number of what? Ion. Strong electrolytes have high conductivity due to the presence of a high number of what? Ions. Strong electrolytes have high conductivity due to high number of what? Due to high number of what? Ions. While weak electrolytes have low conductivity. While weak electrolytes have low conductivity. While weak electrolytes have low conductivity. While weak electrolytes have low conductivity, due to the presence of a low number of ions. While weak electrolytes have low conductivity due to the presence of a low number of what? Ions. While weak electrolytes have low conductivity due to presence of what? A low number of what? Now look up. Remember I said, do you even know what makes this electrolyte to now conduct electricity? Do you know why? Oh, let's round up. After this we go. Do you know why this conduct electricity? Because of these ions. Is that clear?
Yes.
It is ions that makes electrolyte to conduct what? Electricity. So because if this number of if this ion increases, there will be more conductivity. But if the ion is small, there will be low what? Conductivity. Now, because strong electrolytes gives more number of they dissociate completely and give rise to high number of what? Ions. Because if you dissociate completely, more of this will produce, true of us. So if more of this produce, what happen to conductivity?
There will be more
Conductivity.
yes.
Because it dissociates completely to give high number of ions. So there will be more what? High conductivity. But for weak electrolytes, it dissociates partially. So if it doesn't dissociate completely, if a weak electrolyte dissociates partially, that means ion there will be what? Small. Then there will be what? Low conductivity. Does it make sense? Let's finish this comparison. So we do that next in our next class. We are entering principles of mechanism of what? Electrolysis. Okay. The next point. Next point. The concentration of ions in a weak electrolyte solution. The concentration of ion in a strong electrolyte solution, please. The concentration of ion in a strong electrolyte solution. The concentration of ions in a strong electrolyte solution. The concentration of ion in a strong electrolyte solution is equal to the concentration of the electrolytes. The concentration of ions in a strong electrolyte solution is equal to the concentration of the what? Electrolyte. While the concentration of ions in a weak electrolyte solution, while the concentration of ions in a weak electrolyte solution is less than the concentration of the electrolyte. While the concentration of ions in a weak electrolyte solution is less than the concentration of the electrolyte. Why the concentration of ions in a weak electrolyte solution is less than the concentration of the what? Electrolyte. Number four. Examples of strong electrolytes include sodium chloride. That one I use as an example. See the formula. Sodium chloride, hydrochloric acid. These are example of what? Strong electrolytes. Hydrochloric acid, HCl, sodium chloride, NaCl, potassium nitrate. Potassium nitrate, KNO subscript 3. Potassium nitrate, KNO subscript 3. Tetraoxosulfuric acid, H2SO4. Tetraoxosulfuric acid, H2SO4. H2SO4. Tetraoxosulfuric acid, H2SO4. Is that clear? These are examples of what? Strong electrolytes. So that means that these ones dissociate completely, right?
Yes.
And more and high number of electrons produced, which will now make them to be highly what? Conductive. Is that clear?
Yeah.
All right. Next one. Continue. While examples of weak electrolytes are ethanoic acid, CH3COOH. Ethanoic acid, ethanoic. See spelling here. This is IUPAC name. Old name call it acetic acid. The old name call it acetic acid, but the IUPAC name is what? Ethanoic acid. CH3COOH. So it's a weak electrolyte. Ammonia is also a weak electrolyte. Ammonia is also a weak what? Electrolyte. Ammonia. See the formula. NH subscript 3. Then carbonic acid. H2CO3. Carbonic acid. These are examples of what? Weak electrolytes. So there's something I said about concentration. You know, when this thing now dissociate and form ion, concentration of this for a strong electrolyte, concentration of these ions for a strong electrolyte, concentration of this ion is the same thing with concentration of the what? Electrolyte. But for a weak electrolyte, its concentration of the ion is less than the
Like it's less conductive.
We are talking about conductivity. I'm talking about concentration.
Okay.
Listen carefully. For conductivity, I said that strong electrolyte dissociate completely to yield more ions. And I said that is this ion that conduct electricity. So if ion conduct electricity and there is more ion, what will happen to conductivity? If you are the ion,
Yes.
and you are the one that is responsible for conduction of what? Electricity, and I produce more of you, what will happen to conductivity? It will increase now.
Yes.
Now, that is for strong electrolyte. That's why they have high conductivity. But for weak electrolytes, which does not dissociate completely, is partially dissociated partially. That means some still remain like this, while small appear as what? Electrolytes. As I mean ions. So that means there's lower number of ions. What happened to conductivity?
Less.
Huh?
Less conductivity.
Less conductivity
Yes.
in weak electrolytes. Is that clear now?
Yes.
Now, I now said the concentration of electrolytes for a strong electrolyte now, the concentration of the ions produced is the same thing with the concentration of the what? Electrolyte. Do you know why? It dissociates completely. So the ion is same thing. Concentration of what is associated of the result is same thing with what, where it came from. Is that clear? But for a weak electrolyte that does not dissociate completely, only some of it dissociate and form small ions. That means it form a lower concentration of ion with the concentration of the ion form with what? Low than the concentration of the what? Electrolyte, because it only yields small ion. So concentration of that ion produced will be smaller than the concentration of the what? Electrolyte. For weak what? Electrolyte. Is that clear?
Yes.
Are you sure? Good. So I think we'll stop here for today. We have tried for today, haven't we? Yes. Do you have any question? Ask. Which textbook do you use the chemistry? Which textbook do you use the chemistry?
How did I get to know?
I said,
I later use some kind of another textbook. My second textbook, I've used it for another. So I went for Japan. After the book, they gave me another textbook. That textbook exactly.
okay. Which textbook do you use the chemistry? You need textbook to you need textbooks to do science. Not this note will not is not enough for you to do science. And you are doing well, you are bright. Get textbook and study. You are bright, you do well. Which course do you want to study? You do well, you are bright. All you need is to study. Did you hear me? Make sure you get your textbook and study. Though you I don't know whether it covers JAMB syllabus. I'm not sure. I don't know. I've not seen it. But even if it's new school chemistry or essential chemistry, you get it attached to that one. You use for your prep. You tell your parents to buy textbook for you. That you need textbook. It's not those things you copy in lessons is not enough. Most of the things we do here is just to give you a guide. So you need to go back and now get textbook and study. Take it seriously. All right, thank you very much for your attention. See you next time.